Welcome. In search of a game-changing solution for optimizing your manufacturing and industrial processes? Meet MRX Control by McKenna-Rox, the pinnacle of AI-driven control optimization designed to elevate operational efficiency and productivity. With MRX Control, leverage the power of advanced AI to seamlessly manage and optimize your critical facilities and processes. The journey to optimization is fraught with challenges. Companies keen on leveraging optimization technologies face hurdles in fully integrating these solutions into their daily operations. The complexity of existing systems, the need for specialized skills, and resistance to change within organizational cultures make the path to optimization a careful one to navigate. Yet, the pursuit of optimization as an opportunity to revolutionize our approach to industrial processes, driving significant advancements in operational efficiency and heralding a new era of productivity. Companies struggle with understanding the clear cause and effect relationships between control conditions and outcomes, a task made more daunting when efficiency and quality objectives must be met simultaneously. Traditional control logics like PID and MPC often fall short as operational complexity increases. Furthermore, the dynamic nature of industrial environments with continual product, process, and equipment changes challenges the applicability of yesterday's optimization strategies. Variability in operator proficiency further complicates achieving consistent optimization performance. In response to these challenges, McKenna-Rox presents MRX Control, a cutting-edge control optimization solution designed to navigate and surmount these intricate challenges through two key technological innovations. Firstly, the digital twin, a cutting-edge simulator, predicts operational outcomes using finely tuned AI models trained on real equipment data. Its foremost advantage is the utilization of real-world data alongside artificial neural network models, ensuring minimal deviation from actual outcomes and high-speed computation. Secondly, the AI Explorer, driven by reinforcement learning, is working in synergy with the digital twin to uncover the optimal control logic. Its proactive optimization approach, in engagement with the digital twin simulation, overcomes human limitations by actively discovering the most efficient control logic and anticipating future outcomes beyond the capabilities of traditional control methods. This AI Explorer enhances the stability and performance of control operations. This synergy between the digital twin and the AI Explorer leads to significantly improved, consistent, and stable optimization performance. Let's delve into how the MRX control methodology is implemented in the industrial sector. The process begins with the reinforcement learning agent determining the control settings necessary to meet predefined objectives under specific conditions. It then uses the AI-powered digital twin to simulate the operational outcomes of these settings. This iterative procedure involves countless cycles of prediction, comparison against desired outcomes, and analysis of deviations to assign a reward. This reward is crucial feedback for the reinforcement learning agent, steering it towards identifying the most effective control strategy for maximizing performance. Take, for example, optimizing energy efficiency in an electric vehicle's air conditioning system. Here, the reinforcement learning agent receives the current state, along with targets for temperature and energy efficiency. It computes the actuator's control values to achieve these targets and inputs them into the digital twin. The twin then simulates the expected outcomes for temperature and energy efficiency, which are compared against the targets. Based on how closely these simulated outcomes meet the targets, a reward is calculated and fed back to the agent. Through repeated cycles, the agent is guided to discover control values that hit the sweet spot of desired temperature and energy efficiency, demonstrating MRX Control's precision and adaptability in optimizing industrial controls. McKenna-Rox has successfully demonstrated the versatility of the MRX Control methodology across a broad spectrum of applications, proving its effectiveness beyond just electric vehicle air conditioning systems. This innovative approach has been applied to fine-tune industrial machinery, manage the thermal control of furnaces in steel mills, and even optimize the operations of waste incinerator systems. Each of these domains, with their unique challenges and requirements, benefits from the precise control and efficiency improvements offered by MRX Control, showcasing its potential to transform a wide range of industrial processes. MRX Control leverages state-of-the-art technologies for accurate simulations and optimal control logic discovery in complex environments. Its flexibility for on-premises and cloud deployments, coupled with easy integration with systems like DCS, makes MRX Control a pivotal solution for enhancing industrial control efficiency. And so, MRX control is perfectly suited for any industrial environment equipped with accessible data on machine operations and outcomes, looking to elevate control optimization. If you have sample data and are intrigued by the potential enhancements in optimization performance, McKean-Rocks offers a complimentary proof of concept to demonstrate the capabilities of MRX control for your operations. Encountering uncertainties in refining your industrial operations? Allow us to assist you with the innovative MRX control solution, enhancing the precision and efficiency of your processes.